The ancient halls of the Galactic University of Sciences had never seemed quite so quiet as the day the humans arrived. 7 of them stood in the grand atrium, their expressions a mix of wonder and determination as they gazed up at the crystalline architecture that had housed the galaxy's brightest minds for over 10,000 years. They were the first of their species to be accepted into this prestigious institution, an experiment that many faculty members had openly opposed. Professor Zixel adjusted his optical receptors, all 4 of them focusing on the new arrivals. As Dean of Theoretical Sciences, he had been outvoted on the decision to admit humans. Deathworlders, he muttered under his breath, a term that had become common in faculty meetings. The humans' home planet, Earth, had environmental conditions that would kill most sentient species in minutes. They look so fragile, whispered Assistant Professor Crix, her bioluminescent patterns flickering with anxiety. Are we certain they can handle our curriculum? Zixel's external membrane rippled with what passed for amusement among his species. The council insists they've shown promise. We shall see. The first signs that the faculty had severely underestimated their new students came during Professor Zixel's advanced quantum mechanics course. He had assigned what he considered a straightforward problem, calculating the energy requirements for quantum tunneling through various materials. The solution typically required 3 standard approaches taught in the textbook. The human student, Sarah Chen, raised her hand halfway through the lecture. Professor, I have a question about the practical applications. Zixel gestured for her to continue, expecting confusion about the basic principles. Instead, she projected her calculations onto the classroom's holographic display. If we modify the quantum tunneling equation to account for variable particle density, she explained, her fingers dancing across her datapad, couldn't we theoretically create a selective barrier that allows only specific molecular structures to pass through? The classroom fell silent. The other students, representatives of species that had mastered space travel centuries ago, stared at their human classmate. Zixel's optical receptors contracted sharply. That would be. He paused, running the calculations in his enhanced neural processor. Theoretically possible, yes, but the energy requirements would be astronomical. Another human student, Marcus Rodriguez, spoke up without raising his hand. Not if you use the planet's magnetic field as a power source. We've been working on something similar for our engineering project. Zixel felt his primary heart skip a beat. These humans weren't just solving the problems. They were immediately looking for ways to apply the solutions. And not just any applications, but ones that could fundamentally alter the balance of power in the galaxy. A selective molecular barrier could revolutionize everything from medicine to military defense. The pattern continued across other classes. In advanced xenobiology, the humans suggested modifications to existing life support systems that would allow species to survive in previously hostile environments. In theoretical mathematics, they found new ways to optimize hyperspace calculations that cut transit times by 30%. But it was during the practical exercises that the faculty's concern truly deepened. The humans approached every problem as if their survival depended on it, finding solutions that were elegant in their brutality and efficient in their simplicity. They're not just learning, Professor Crix observed during an emergency faculty meeting 3 months into the term. They're adapting our most advanced theories to solve problems we didn't even know we had. The meeting hall erupted in nervous chatter. Tentacles waved, antennae twitched, and bioluminescent patterns flashed in agitation. Zixel raised all 4 arms for silence. The question before us, he said, his voice resonating through the chamber, is whether we continue as planned. These humans, he projected the latest test results, are performing far above expectations. But their approach to problem-solving is disturbing, finished Professor Vorn, his crystalline form shimmering with concern. Every solution they propose has dual applications. Scientific advancement, yes, but also potential for progress, interrupted a voice from the doorway. The faculty turned to find Sarah Chen standing there, datapad in hand. We call it progress, Professor Vorn, and we've just solved the quantum entanglement stability problem you've been working on for the past decade." The silence that followed was deafening. Zixel felt his secondary heart join his primary in arrhythmic protest. The humans hadn't just adapted to the university's advanced curriculum. They were beginning to surpass it. As Sarah handed over her calculations and quietly left the room, Zixel couldn't help but wonder. Had they made a terrible mistake in allowing humans into the galaxy's most prestigious institution? Or was this precisely why the Galactic Council had insisted on their inclusion? The answer, he suspected, would change the course of galactic history. The only question was whether that change would lead to unprecedented advancement or unimaginable chaos. As he reviewed Sarah's elegant solution to a problem that had stumped him for years, he realized with growing certainty that it would probably lead to both. For the first time in his long academic career, Professor Zixel found himself learning from his students, and that perhaps was the most terrifying revelation of all. The massive engineering lab of the Galactic University hummed with activity as students from across the cosmos worked on their semester projects. Professor Telix, a veteran of structural engineering whose silicon-based form had personally overseen the construction of 3 space elevators, watched with growing concern as the human students gathered around their assigned workspace. The project was simple: design and construct a self-repairing habitat suitable for any environment. It was meant to teach basic principles of universal architecture, the kind of assignment first-year students had completed without incident for centuries. Marcus Rodriguez and his project partner, Jin Wei, had other ideas. The traditional approach is inefficient, Jin explained to a cluster of fascinated Arxian students, their crystalline bodies reflecting the holographic blueprints floating above the workstation. Why build something that only repairs itself when you can build something that evolves? Professor Telix drifted closer, his crystalline sensors vibrating with interest. The humans had completely redesigned the basic habitat structure, incorporating principles that seemed to draw from Earth's natural systems. "See, we based it on coral reefs," Marcus continued, manipulating the hologram to show the internal structure. "The habitat doesn't just repair damage. It learns from it. Each time there's stress on the structure, it reconfigures to better handle that specific type of pressure." An Arxian student, its crystalline form glowing with excitement, raised an appendage. "But what about the energy requirements?" Jin smiled, pulling up another diagram. "That's where it gets interesting. We've incorporated modified versions of Earth's extremophile bacteria into the building material. They generate energy from almost anything: heat, pressure, chemical reactions. The more stress the habitat faces, the stronger it becomes." Professor Telix felt his silicon matrix vibrate with alarm. These humans weren't just building a shelter, they were creating a living fortress, a structure that could theoretically survive any attack by using the enemy's own force against it. "Fascinating approach," he interjected, trying to keep his tone neutral. "But perhaps we should focus on more traditional methods." "With respect, Professor," Marcus replied, his eyes never leaving the hologram, "traditional methods don't survive on Deathworlds. We're just applying what we learned on Earth." The word Deathworld sent a ripple through the gathered students. Most species evolved on worlds far more forgiving than Earth, where survival didn't require constant adaptation and innovation. The idea that humans had developed under conditions that would kill most sentient beings was both fascinating and terrifying. As the weeks passed, the human design proved more revolutionary than anyone anticipated. The prototype habitat, though small, demonstrated remarkable abilities. When exposed to extreme heat, it developed cooling systems more efficient than anything in the standard curriculum. Under pressure, it grew structural reinforcements that defied conventional engineering principles. But it was during the final testing phase that the true implications became clear. "Watch this," Jin said during the presentation, her voice filled with pride. She activated a small device, and suddenly the habitat's surface became completely invisible. The audience gasped. Professor Telix felt his crystalline structure vibrate at a frequency usually associated with extreme distress. The structure learns to bend light around itself when it detects potential threats, Marcus explained casually, as if he hadn't just demonstrated technology that most military forces would kill to possess. It's just another adaptation, like developing stronger walls or better temperature regulation. The silence in the lab was deafening. Then, unexpectedly, applause erupted from the Arxian students. Other species joined in, their various appendages creating a cacophony of appreciation. Professor Telix watched in growing concern as students crowded around the humans, asking questions about adaptation and evolution, about survival and innovation. Later that day, in an emergency faculty meeting, Professor Telix's report caused considerable alarm. They're not just influencing their fellow students, he explained, projecting images of various species' habitat designs. Look at how the other projects have changed over the semester. The Arxians have incorporated adaptive crystalline structures. The Volks are experimenting with biological integration. Even the Zentari, who haven't changed their engineering principles in 10,000 years, are talking about evolutionary architecture. Dean Zixel, who had been unusually quiet since the quantum mechanics incident, finally spoke. Perhaps this is precisely what the Council hoped for when they admitted humans to our institution. New perspectives, new approaches, new weapons, Professor Crix interrupted, her bioluminescence pulsing with anxiety. Everything they create has defensive applications. Every innovation could be used for protection, or conquest, or survival, Professor Telix countered, surprising himself. Have we considered that perhaps their approach to engineering, their constant preparation for the worst, comes not from aggression but from necessity? They evolved on a world that tried to kill them at every turn. Of course they build as if their lives depend on it, because on their world it did. The faculty fell silent, considering this perspective. In the lab below, Marcus and Jin continued working late into the night, their habitat growing and adapting, learning and evolving. Around them, students of a dozen species watched and learned, their own projects slowly incorporating elements of human innovation. The engineering incident, as it came to be known, marked a turning point at the Galactic University. It was the moment when human influence began to spread beyond mere academic curiosity into something more profound. A fundamental shift in how the galaxy's brightest minds approached problems. And as Professor Telix watched his students embrace this new way of thinking, he couldn't decide whether he was witnessing the beginning of a renaissance or a revolution. Perhaps, he reflected, watching the habitat shimmer into invisibility once again, they were one and the same. The Galactic University's Crisis Response Center was designed to test students' reactions to emergency scenarios. Today, it would test the faculty's assumptions about their human students in ways no one had anticipated. Begin Simulation Alpha 7, announced Professor Vex, her gelatinous form pulsing with different colors as she activated the holographic environment. The vast chamber transformed into a deep space scenario, a damaged station orbiting a dying star. The mixed species student teams took their positions. This was supposed to be a standard evacuation drill, the kind the university had run thousands of times before. The goal was simple: save as many lives as possible while maintaining essential systems. Sarah Chen and her team, however, had other ideas. "We're not evacuating," she announced, her fingers flying over the control panel. Her teammates, two Arxians, a Volks, and Marcus Rodriguez, moved with practiced precision, as if they'd rehearsed this scenario countless times. Professor Vex's color patterns shifted to alarmed purple. "The simulation parameters require evacuation, Ms. Chen. The station's structural integrity can be maintained," Marcus interrupted, pulling up a series of calculations. "Sarah, show them." The holographic display filled with data streams. Sarah had completely reconfigured the station's power distribution, channeling energy from non-essential systems into a makeshift containment field. Meanwhile, Marcus had reprogrammed maintenance drones to reinforce failing sections of the hull using debris from damaged areas. The traditional evacuation protocols waste too much time and resources, Sarah explained, her voice calm despite the simulated alarms blaring around them. And they assume failure is inevitable. We're proving it isn't. Professor Vex watched in stunned silence as the human-led team not only prevented the station's destruction, but began using the dying star's increased radiation to power their improvised repairs. It was elegant, efficient, and completely outside standard emergency procedures. Other teams had stopped their evacuation efforts and were watching the humans work. The Arxians on Sarah's team had adapted their crystalline computing abilities to enhance the containment field, while the Volks used their natural understanding of energy flows to fine-tune the power distribution. This isn't just about saving the station, Marcus explained to the observing students, his hand steady as he guided a drone through a particularly delicate repair. It's about saving everything. The research, the infrastructure, the investment of resources. An evacuation means starting over. We're proving you don't have to. In the control room, Professor Vex was joined by Dean Zixel and other faculty members. They watched as the humans transformed what should have been a simple evacuation drill into a masterclass in crisis innovation. They're treating it like a war, Professor Crix observed, her bioluminescence flickering anxiously. No, Dean Zixel corrected. All 4 of his optical receptors focused intently on the scene. They're treating it like survival. There's a difference. The simulation continued, but it had become clear that the original parameters were now irrelevant. The human approach had completely changed the scenario's dynamics. Instead of an orderly retreat, they had turned it into a fight for preservation against seemingly impossible odds. And they were winning. Look at their teammates, Professor Telix noted, his crystalline form vibrating with something between concern and admiration. They're not just following the humans' lead. They're anticipating their needs, adapting their own abilities to complement the humans' strategies. He was right. The Arxians had developed new crystalline configurations to enhance the containment field's efficiency. The Volks had discovered ways to channel energy that even their own species had never considered. The integration of different species' abilities with human innovation was creating something entirely new. As the simulation entered its final phase, Sarah's team had not only stabilized the station, but had begun using the star's death throes to power significant upgrades to the facility's systems. What should have been a disaster had become an opportunity for improvement. End simulation, Professor Vex announced, her form now a confused swirl of colors. The holographic environment faded, leaving the team standing in the empty chamber. The silence that followed was broken by applause, not from the faculty, but from the other students. Species that had been following the same emergency protocols for generations were suddenly seeing new possibilities, new ways to approach crisis situations. In the faculty observation room, the implications were not lost on anyone. The humans weren't just solving problems differently. They were changing how everyone else solved problems too. We need to discuss this, Professor Crix insisted, her patterns flashing with urgency. Their influence on the other students is precisely what's supposed to happen in a university, Dean Zixel interrupted. They're learning from each other. The question is, are we willing to learn as well? The Crisis Response Center slowly emptied, but the impact of that day's simulation would ripple through the university for months to come. Emergency protocols were rewritten, incorporating elements of human adaptability. Students began approaching problems with a new mindset, one that viewed obstacles not as signals for retreat, but as challenges to be overcome. And in their private quarters that evening, Sarah and Marcus reviewed the simulation data, already planning improvements for next time. Because for humans, there was always a next time, always another challenge to face, another problem to solve. They weren't just surviving anymore. They were teaching the galaxy how to thrive. The grand hall of the Galactic University buzzed with an energy that made even the crystalline architecture seem to vibrate. The annual Interspecies Academic Olympics, traditionally a showcase of established theoretical approaches, was about to be transformed forever. The rules are simple, announced Chancellor Vorks, his energy form flickering with formal patterns. Each team will face 3 challenges: theoretical physics, applied engineering, and crisis response. The winners will have their research fully funded for the next academic cycle. In the participant area, Sarah Chen and Marcus Rodriguez sat with their unusually diverse team. Besides the 2 humans, they had recruited Jin Wei, 2 Arxians named Crystal Song and Lightweaver, and a Volts energy specialist called Pulse. Most teams stuck to their own species. This was unheard of. The first challenge begins now, the Chancellor declared. Calculate the optimal method for stabilizing a quantum singularity. The holoprojectors activated, filling the space above each team with swirling equations and diagrams. Traditional approaches involved complex mathematical models developed over centuries of research. The human team took one look at the problem and did something completely different. "We're approaching this wrong," Sarah announced to her teammates. "Everyone tries to control a singularity from the outside. What if we work with it instead?" The Arxians' crystalline forms sparkled with interest as Sarah explained her theory. Instead of fighting the singularity's pull, they could use its own properties to create a self-stabilizing system. Jin's fingers flew across their console, translating the concept into mathematical reality. Around them, other teams worked with focused determination, following well-established methods. But as the solutions began appearing on the main display, the difference was stark. While other teams produced variations on known approaches, the human team's solution was revolutionary. "Impossible," muttered Professor Zixel from the judges' panel, all 4 optical receptors widening. They turned the singularity's own gravitational effects into a containment mechanism. "It's elegant." The murmurs from the audience grew louder as the implications became clear. The humans hadn't just solved the problem, they'd reimagined it entirely. And their alien teammates had contributed crucial insights that made the solution even more robust. The engineering challenge proved even more surprising. Teams were tasked with designing a self-sustaining habitat for a hostile environment. While others created conventional structures with standard protective measures, the human team drew inspiration from Earth's extremophiles. "Life finds a way," Marcus explained as their design took shape. "We're not building a shelter, we're creating an ecosystem." Their habitat incorporated living elements that adapted to threats, much like their earlier project, but now enhanced by the Arxians' crystalline architecture and the Volks' energy manipulation. It wasn't just a building. It was an evolving system that learned from its environment. But it was the crisis response challenge that truly shocked everyone. The scenario: a planetary system facing imminent destruction from its dying sun. The expected solution was to calculate evacuation routes and priorities. Instead, the human team proposed something audacious. "We can move the planets," Sarah announced calmly. The silence in the grand hall was absolute. "Impossible," someone in the audience declared. "Watch," Jin replied, bringing up their calculations. Using a combination of quantum tunneling, gravitational manipulation, and energy transfer methods they'd developed over the semester, they demonstrated how to relocate entire worlds. The Arxians contributed their knowledge of crystalline computing to handle the complex calculations, while Pulse's energy expertise helped solve the power requirements. "This isn't just theoretical," Marcus explained to the stunned judges. "We've scaled it down and tested the principles in the lab. It works." The implications were staggering. They hadn't just solved the challenge. They'd developed technology that could reshape the galaxy. And they'd done it by combining human innovation with alien expertise in ways no one had thought possible. The judges huddled in intense discussion, their various forms expressing agitation in species-specific ways. Finally, Chancellor Vorks approached the podium. "In the history of this competition," he began, his energy form pulsing with unusual patterns, "we have never seen solutions that so completely transcend our expectations. The human team has not only won but has demonstrated the true potential of interspecies collaboration." The applause that followed was thunderous. But among the faculty, concerned whispers circulated. Professor Crick's bioluminescent patterns flashed warning colors as she leaned toward Dean Zixel. "They're not just excelling," she whispered. "They're rewriting the rules of what's possible. And they're bringing others with them." Indeed, throughout the audience, students from various species were already discussing the implications of the human team's approaches. Ideas were spreading, perspectives shifting, possibilities expanding. Later that evening, as the human team celebrated their victory, Sarah noticed something remarkable. In corners of the grand hall, small groups of students from different species had formed, discussing new ideas and possibilities. The barriers between species were breaking down, replaced by a shared excitement about what they could achieve together. "We didn't just win a competition today," she told Marcus as they watched their Arxian teammates explain their calculations to a fascinated group of Volk students. "We started something bigger." Marcus nodded, understanding the significance. "They're not afraid of our ideas anymore. They're inspired by them." As the celebration continued, Dean Zixel watched from his office overlooking the grand hall. The humans hadn't just changed the competition. They had changed the very nature of interspecies academic collaboration. Whether this change would lead to a golden age of innovation or unleash forces beyond control remained to be seen. But one thing was certain: the galaxy would never be the same. The ceremonial chamber of the Galactic University glowed with an ethereal light as thousands of beings gathered for the graduation ceremony. Among them sat 7 humans, the first of their kind to complete the prestigious program. The air hummed with tension and anticipation. Chancellor Vork's energy form shimmered at the podium, addressing the assembled graduates and faculty. "When we first opened our doors to students from Earth, many questioned the wisdom of admitting Deathworlders to our hallowed institution. Today, we acknowledge that this decision has transformed our understanding of what is possible." In the front row, Sarah Chen and Marcus Rodriguez exchanged glances. Their final projects lay sealed in quantum-locked containers, innovations so profound that the University Council had immediately classified them as restricted knowledge. Next to them sat their teammates: Jin Wei, Crystal Song, Lightweaver, and Pulse, their diverse forms a testament to the new era of collaboration they had helped create. "The traditional purpose of this institution," Chancellor Vork's continued, "has been to preserve and gradually advance galactic knowledge. Instead, we find ourselves at the dawn of what some are calling the Great Acceleration." Professor Zixel, seated among the senior faculty, remembered his initial skepticism about the humans. Now, 3 years later, his 4 optical receptors had difficulty processing how much had changed. The humans hadn't just learned, they had catalyzed an evolutionary leap in educational methodology. "Our graduating class has achieved something unprecedented," the Chancellor declared. "They have not merely mastered our curriculum, they have transcended it. The barriers between disciplines, between species, between what we thought possible and impossible, have been fundamentally altered." The chamber's crystalline walls reflected images of the year's achievements: the quantum tunneling breakthrough, the adaptive architecture project, the crisis response innovations. Each discovery had built upon the last, creating a cascade of advancements that had attracted attention from across the galaxy. But perhaps the most remarkable achievement, Chancellor Vork's continued, his energy form pulsing with complex patterns, has been the emergence of true interspecies collaboration. The human approach to problem-solving, combined with the unique abilities of other species, has created something entirely new. In the audience, representatives from various galactic institutions watched with intense interest. The graduates they were observing had already received countless offers from research facilities, engineering corps, and even military think tanks. The humans and their closest collaborators were particularly sought after. Sarah stood to deliver the valedictory address, her presence commanding attention despite her small stature among the varied species. "When we arrived here," she began, "we were seen as anomalies, creatures from a death world who had somehow achieved space travel. But what our time here has shown is that diversity of experience, of perspective, of evolution itself, is not a weakness, but our greatest strength. She gestured to her teammates. Crystal Song and Light Weaver taught us how to think in crystalline patterns, expanding our computational abilities. Pulse showed us how to see energy as a living force. We taught them how to view obstacles as opportunities, how to turn survival into innovation. Together, we've proven that the sum of our differences is greater than any individual species' achievements. The chamber fell silent as her words resonated. Even the most conservative faculty members couldn't deny the evidence before them. The graduating class had produced more breakthrough discoveries than the previous 50 years combined. As we leave these halls, Sarah continued, we carry with us not just knowledge, but a new way of thinking. On Earth, we have a saying, necessity is the mother of invention. Our necessity was survival on a death world. But here, we've learned that survival isn't enough. We must thrive, and we must help others thrive as well. Professor Cricks, watching from her position among the faculty, noted how her own bioluminescent patterns had changed over the years. The anxiety she had once felt around humans had transformed into a complex mixture of respect and anticipation. They changed us all, she whispered to Professor Telix. The silicon-based engineer nodded, not through force or fear, but through inspiration. They showed us possibilities we never imagined. As the ceremony concluded, the graduates filed out into the grand atrium. The humans, once viewed with suspicion and fear, were now surrounded by admirers from dozens of species. Their approaches to problem-solving had spread beyond the university, influencing research and development across the galaxy. Dean Zixel approached Sarah and Marcus as they prepared to leave. When you first arrived, he said, his voice modulator conveying a complex mix of emotions, I feared you would disrupt our carefully ordered systems. I was right, but not in the way I expected. You've taught us that progress isn't about maintaining order. It's about embracing chaos and finding the patterns within it. Sarah smiled. We just did what humans always do, Professor. We adapted, we innovated, and we shared what we learned. And in doing so, Marcus added, we helped create something bigger than ourselves. As the humans departed the Galactic University that day, they left behind more than just their groundbreaking research. They had planted seeds of change that would continue to grow and evolve. The galaxy was entering a new age, one where the lessons of a death world would help all species not just survive, but flourish. The experiment of admitting humans to the galaxy's most prestigious institution hadn't just succeeded. It had redefined success itself. And somewhere on Earth, another group of students was preparing for their journey to the stars, ready to continue the legacy of those who had gone before. The Deathworlders had not just transformed a math class into tactical warfare, they had transformed the future itself.